Hello everyone. Today's video is going to be about deriving Laplace transform of e to the power of at, which seems like a pretty elementary function. Having exponential there, it seems like one of the most basic functions you could have in a tutorial on using Laplace transform. So I just thought, why not do that? Also, it happens to be very useful in shifting a function, which is a Laplace property I'm going to discuss later. But yeah, actually I might just integrate it into this video. I don't know. I'll see how I'm going to be doing for timing. And if it happens that I'm running out of time, then I won't do it. For now, I just press on. So this is what it equals. Note that this is the same thing as this improper integral. This is just basic indices rules, right? But you need like grade 7 or year 7 knowledge to solve this. It's not anything particularly difficult. And we can factorize it so that you have a minus s. This is a constant. So that means that if we take just the regular indefinite integral, what you're going to end up with is you're going to have 1 over a minus s times this. Okay, so we're just going to evaluate it quickly. We have, by the way, this is like the third take. I tried to film this 3 times, and in each one of them it took me like 25 minutes, so hopefully it will take much less this time. Yeah, I can see that a new setup with the projector is not really working with the camera, so I'm just going to have to hold it, okay? And then, yep. What we're trying to do is find it has to be as follows. Just kind of push the limit here, and and then what you're going to have here is very interesting. If s is bigger than a, then this will actually converge. It will converge towards 0. But if a is bigger than s, what you're going to have is you're going to have a number that's positive here, a positive coefficient of t, which means that it's not going to converge, it's going to diverge. Let's quickly write it here. Sorry for the rubbish handwriting. And if a is equal to s, you're just going to have a 0. Let's evaluate each of those cases. It's not going to be 0, sorry, it's going to be, this is going to be 0. But the whole expression here will be e to the power of 0, which is 1. So we're going to rule out this case, but we're going to treat this case as undesired, and this one as the optimal case, because that's when we're going to have 0 and need 0 to allow us to kind of focus on what we get here. So yeah, so what we have here, actually might as well just kind of move to here. What we have here is, I have 1 minute left basically. Okay, so I'm going to do it quickly. 1 over a minus s of, essentially, because this is, we said this is going to be 0 because e to the t times a negative number when t approaches infinity is going to be 0. We're going to have 0 minus what? 0 minus e to the t dA minus s when t is 0, so it's just going to be 0, so 1. So 1. That's going to be that. I don't know why I put in the modulus modulus-like symbol. Must be quite confused. Anyway, add the same thing as this. And this is equal to minus 1 over a minus s. Just gonna make it neater, that's what we're gonna get. And we are done. Yep, sorry, I keep doing this. So the Laplace transform of e to the at is 1 over s minus a. I'm gonna do the property of this function later. So yeah, for now, see ya.